Okay, so today we are going to step it up from complex fractions and unit rates and head into our other vocabulary word, proportional relationships. So we're going to look at, this is what you want to write in your table of contents, people. And yes, I am yelling at you right now to write this down in your table of contents with the date today. Me to check it in class. So identifying proportional relationships. We're looking at identifying them. Okay? So you're writing that in. If you need time to write it, pause the video because I'm moving on. So first thing, there was one vocab word that we did not get to. We got to talk about the one vocab word, proportional relationships, right? And you guys were good with that one. Definition being when two ratios are equivalent. Two ratios are equivalent. Okay, we figured out if you have that, they're going to be in a proportional relationship. Now, the next one that we're going to finish in class, and we're going to do the note card in class tomorrow, is called, and we're going to do it in our notes right now, the constant of proportionality. Okay, this one you want in your notes, the constant of proportionality. So the only way to actually have a constant of proportionality is to have a proportional relationship. Okay? And what the heck is the constant of proportionality? Well, if I have a proportional relationship happening and I have ratios that are equivalent, the constant of proportionality is that ratio. It's the ratio of how they are equivalent. So we represent this in math as a variable. You'll see it depicted as K, also known as AKA the unit rate. You can also see it that way in mathematics. And to find it, when you're given x, y coordinates in a graph or on a table, you would take the y and divide it by the x. That would be your ratio. And that ratio is equivalent to k. This might be totally confusing to you right now. So let's actually just try a problem out, okay? Yes, you can do this. Be strong. I'm talking to you guys. Okay, you're going to copy down this table in your notes. And this is about a scientist. So example, this one's about a scientist recording data collected by a rover sent to the planet Mars. So we'll label this Mars. The scientist recorded the time it took the rover to travel several different distances. So the rover traveled 2 seconds and it went 10 centimeters. Traveled 6 seconds, went 30 centimeters. Traveled 3 seconds, went 15 centimeters, and so forth. Identify and interpret the constant of proportionality for this situation. Identify and interpret the constant of proportionality for this situation. Okay, so we need to identify the constant of proportionality. Well, if we need to identify it, then it must mean that this situation is proportional. Okay, so if it's proportional, the ratios between x and y here, my x-y pairs, are equivalent. The ratios here that I see are supposed to be equivalent to each other. Do you agree? Well, let's check it out. So let's simplify. Step 1, simplify each ratio. So let's start with the first one here, 2 seconds for 10 centimeters. Now what I labeled before, the constant of proportionality, is the ratio y to x. So my first ratio is going to be 10 to 2. 10 to 2. My next ratio, looking up here, would be 30 to 6. Third ratio, 15 to 3. Next one, 45 to 9. And the last one, 20 to 4. And I'm going to simplify each one of these. 10 to 2 simplifies, divide them both by 2, and I'm at 5 to 1, which is just 5. 30 divided by 6. Hey, that's 5. 15 divided by 3 is 5. 45 divided by 9 is 5. 20 divided by 4 is 5. They are all equivalent to 5, meaning that we have a proportional relationship, and our constant of proportionality, can you guess what it is? It's 5. 5 to 1. So we have the ratio. I'm going to write it here. We simplified all those down, and it was 5 to 1, right? Because I divided both these by 2 and got 5 to 1. Divide both these by 6, got 5 to 1. Divide both these by 3, got 5 to 1. Divide both these by 9, got 5 to 1, and so forth. So here is my constant of proportionality. I identified it. That's what it is, where they all remain the same. Now if I interpret that, what does that mean? Well, it means the rover, right? The rover's speed is what? 5, what's my unit? 5 centimeters per 1 second. Okay? So the constant of proportionality is 5, because 5 divided by 1 is 5. And then what does it represent? It represents the rover's speed at 5 centimeters per second. Okay, one more to try. Okay, let's say we're given this is called a map diagram, where we map x values to y values. Okay? And we're asked, so we'll label this as mapping, mathematical mapping. Is this relationship directly proportional? If so, identify the constant of proportionality. All right, we need to see if it's proportional. Well, to see if it's proportional, the ratios would be equivalent. So what am I going to have to do? Well, I'm going to have to write out those ratios. So step 1, write out the ratios. And the ratios need to be y to x. My first pairing, 3, my y value gets paired with 9. Second one, I'm going to see, is it equal to 4 to 12? Is that equivalent to 5 to 15? And is that equivalent to 6 to 18? And is that the same as 7 to 21? We are questioning this. Do we think it's proportional? Is it a proportional relationship? Well, let's simplify all these things. I could divide both these by 7, and I'm at 1/3. 3/9. Divide both those by 3, and I'm at 1/3. Divide 4/12 by 4 over 4, and I'm at 1/3. Divide by 5 and 5, and I'm at 1/3. Divide by 6 and 6, and I'm at, oh my gosh, what do you know? 1/3. What does this mean when they are all equivalent to each other? That this is a proportional relationship. And if it's a proportional relationship, we should then be able to identify the constant of proportionality. So what is our constant of proportionality? Well, hopefully you know now. I wonder. It's right there. The constant of proportionality in this proportional relationship is 1/3. Cha-ching! We're going to practice this in class, so see you then.